Alright kiddos, here's going to be a short version of how to do linear programming, or not linear programming, linear regression, or later on any other type of regression on your calculators for Algebra 2 and Pre-Calc. So to start with, I'm just going to pick a problem. In this case, for Algebra 2 crew, we're doing Chapter 2, Section 5, using linear models. It's page 96. I'm going to do number 12. It's the very first one in our assignment. So you start by trying to input your data. Remember that typically, if you have anything related to time, that's going to be in your x values. If you have anything else, that's your y, because time is almost always an independent variable, since everything in the universe depends on time. We're going to start by, to enter your data, stat, edit. And I've already typed in our values for problem 12, pork production in China. Don't know why we care about that, but hey, that's the problem. If you'll notice, for my years, we always start with our first data point. Even though it's the year 2000, I'm going to start with 0. Your first data point should be 0, because otherwise, when we find this model, when I find a linear equation for it, if I actually put in the year 2000, it's going to make a model going all the way back to the year 0, and you're going to find out that the government had to pay you $3 billion for you to have pork in the year 0, something ridiculous. So our first data point when we're dealing with time is going to be 0, and then years or months or whatever since then. So that's my list 1. List 2 is the metric tons of pig that we're making. Once you have this, to find your linear model for it, we're going to go back to stat and we're going to calculate a linear regression line. Now on a TI84, it's going to pop up with this asking you what lists you want and where you want to store it. So list 1 was my x's, list 2 was my y's. And to store it, I can either go for my variables menu, or if I hit alpha, and these guys up here all have a little shortcut menu. So if I hit alpha trace, it'll say y1. I want to store this equation we're making into y1 so I can graph it. And I will calculate, and there's my equation. So I'd write this down on my paper. That is my model. Here's my slope, here's my y-intercept. Now to graph it. If I try to graph right now, unless it's stuck on something else I was doing in class, I don't actually see the graph. Well, that's because if you noticed, we had a slope of 2,000 something and a y-intercept around 40,000. So my window needs to be a lot bigger, and you need to shut up, stupid computer. There we go. So I can manually change my window. I can say I'm going to go from 0, remember x is my years, out to, well, this went to 2007, so we need to go out at least 7 years. I'm going to go out, say, 30 years, just to be safe, because I have to extrapolate, if you read the rest of the problem, out to the year 2025. And my y's, I'm going to go from 0 piggy up to, my data goes to 54,000. I'm going to go further. Maybe we'll go, say, 80,000. Or no, one of my questions in the problem says to go out to 100. So let's change that to 110,000. So I can manually change my window. Ignore this, that's from a different lesson today. And if I want all of my points on here that were actually part of my data set, I can go to second, stat plot. And, well, first I'm going to turn my plots off, because that's where that box and whisker plot came from. Let's go back there. I'm going to turn plot 1 on, and I'm going to make sure it's a scatter plot. And I want my x's to come from list 2, my y's, or x's from list 1, y's from list 2, just like we finished doing. And just for a little contrast, I'm going to change those to, say, green, just so we can see our points better. Now when I graph, I can see the points. Now I made this graph really big because I know what's coming in the rest of the questions in my problem, because I read the problem before punching buttons. Always a good thing to do. If not, let's say we were way back at a standard grid. Okay, I hit graph and I ended up with this, and I can't see what I'm doing. Well, if you turn that stat plot on, now I can zoom to my statistics. And it'll zoom straight in on those data points. Okay, so I have a model. That's part A. Part B says predict how many tons of pork will be produced in 2025. Well, if I try to trace this, first of all, right now it's tracing on the plot 1. If I try to type in 2025, see, it quits my trace program, because if I try to trace this and I'm on my plot, well, the year 2025 wasn't on my plot. In fact, 20 anything isn't on my plot because I put it in years since 2000. So I need to go down. So now I'm on my graph, and then I can type in the year 25 because that's 25 years since 2000. So 25. And I hit enter and it says, uh-oh, you can't do that because it's not in my window. Your window has to be big enough to see whatever you're trying to trace to. So again, I'm going to go back to my window, make this bigger like we just got done doing. I'm going to go out 30 years, and I'm going to go out to 110,000. Definitely want to change that, because if I try to do this right now, you're asking to find in between a minimum and a maximum that are backwards. So it'll tell you you're screwed up again. You'll get another error message. So I'm going to switch this back to 0. Just to be safe, we'll make this 0, and to make the graph pretty, I'm going to make my scales by 5s and by, say, 10,000. Graph. Okay, now I see everything nice and pretty. So now again, we're going to trace. I'm going to go to my graph, and I want to trace out until it is at 25 years away. Lo and behold, this is how much I got. Always pay attention to the context of the problem, though, because it's saying production in metric tons. So you're going to have 91,000 metric tons. That actually means you're talking about 91 million pounds of pork, or metric tons. So that'd be 91 million kilograms of pork. That's a lot of pigs. Part C asks you to predict when the production is likely to reach 100,000. Well, the x-axis, that was time. The y-axis was the amount of production. So if I want to find when the y-axis hits 100,000, either I can just keep on tracing out until I get close to 100,000, and I can ballpark it. Say it's about 29 and change, so about the year 2029. Or if I go to Y2 and I type in 100,000, back to my graph, I can calculate this intersection using my calculate feature. So I will calculate the intersection between graph 1, it doesn't actually matter where Blinky is here, and graph 2, again, doesn't matter. It's going to ask you for a guess. You can put your guess over here if you want. I really don't care because it will give me the answer. In the year 2029, I'll have 100,000 metric tons of pig. So that's the quick rundown on how to do your linear regression. It's going to be the same process for quadratic and cubic and quartic and all kinds of other regressions we'll do later, but that's the general idea. Now, something I want to bring up is you guys don't have an 84 emulator on your computer, but you do have an 83. If you go to your All Programs and on down to Texas Instruments, you have a Flash debugger. It's this old school emulator. So we choose New. You can choose your calculator. Don't choose 73, they're lame. Silver just changes the color. and I have to hit play in order to get this. So I can still stat and edit, it's just lamer colors. When you go to do your regression, now remember on here, when I hit stat, calculate my regression, it had this pop-up menu. Well, on here, I go stat, calculate my linear regression, it doesn't bring that pop-up menu. So if I wanted to change my list, I would have to say, for example, list 2, comma, list 4. Oh, clear, go away. This is saying do a linear regression using my x's from list 2, my y's from list 4. And if I wanted to store it like we do here, I'd have to hit comma, variables, go to y variables. I want to put it in the function y1. So you just have to manually put those things in instead of getting a pop-up window when you're using an 83. So hopefully this helps us out, and all else fails, ask.